Good morning, everybody. First of all, thank you. And today we are looking at dynamic of jellyfish swarms and unraveling the intricate influence of coastal ocean parameter in southeastern Arabian Sea. So as we know, what is the background of this basic jellyfish from polyps to medusa. So it was lived in millions of years ago, and its life cycles, sexual and asexual stages, and we can able to see wherever in the oceans from it is a sorry. Okay, and this is a major drastic for our fisheries and tourism and even and other vice versa. So this is the aim of the investigation. Sorry, I'm not on a biology background, so that's why I'm just a little bit struggle for telling these things. And aim of the investigation is to unraveling the intricate influence of coastal ocean parameter in the southeastern Arabian Sea. So this is my study area, and which is located in Eastern Arabian Sea in Cochin, Kerala, west coast of India. And so we are onboard survey were monitored multi-dated over 2018 and 2019 period. And what are the parameters we are studied means which is temperature, salinity, surface current, and meridional wind component, and other phenomena of upwelling and downwelling we can study. And this is a methodology, basic methodology. So the data occurred from ICAR model output. So and correlate with that jellyfish catching data, and relationship between the bloom and temperature and salinity, and how the Ekman pumping associated wind stress influenced during upwelling and downwelling phenomena, and time series of temperature, salinity, surface current, and influence in the bloom dynamics. And this is a thing, just I am telling, first figure, red color shows the jellyfish catching in multi-dated period over 2018 and 2019. And this is a spring intermonsoon 2018, and this is a summer monsoon, southwest and northeast monsoon. This is 2019, summer southwest and northeast monsoon. And red color shows the jellyfish catching, and this one shows the wind stress parameters, and B which shows meridional wind component, and D sea level anomaly. This is sea level anomaly, and sea surface salinity, and Ekman pumping, and Ekman transport, wind stress curl, and finally SST. So how these parameters influenced in this correlate in jellyfish catching during the days. In spring intermonsoon, we cannot get any jellyfish catching, and even summer monsoon and northeast monsoon, we can see the peak. So these days, particularly in bloom jellyfish bloom, in blue color shadow mark zone, it shows in the 2018 Kerala flood season. During the time, it was in more upwelling period. This period, but this is downwelling during downwelling in northeast monsoon, and upwelling and downwelling is the more influenced in bloom dynamics. And this wind stress is the positive and negative values. Positive wind stress and negative wind stress, what is it means in coming to the following slide, I will tell you elaborately. And this is the this is meridional wind component. Positive value means upward direction is the positive, and negative is the downward direction. So upward is the northward movement. It is negative value means which represent the southward movement of the wind current. And sea surface salinity. So this is sea level anomaly. So sea level anomaly, positive value and negative value. Positive value normally happen, the water push towards the offshore, push towards the sea means the water level increased, and the level decreased means it shows to the upwelling signal. So these particular places showing in upwelling. And D is the sea surface salinity. Salinity, wherever the bloom. So that time we can able to see the decreased trend. The salinity decreased during the time of bloom dynamics. And Ekman pump. This is Ekman pumping. So Ekman pumping, positive and negative. So Ekman pumping is nothing but it is a push the water towards downside and upward directions. So negative negative pumping. So always in the ocean, jellyfish bloom was more intensity during the time in wherever we can get negative pumping. And Ekman transport EF. So this is Ekman transport. So sorry for the interrupts. And Ekman transport, it shows a zero symmetrical line. So a little bit up positive Ekman transport shows the more catching of the catching timer. So it is an symmetrical line. So negative, it was in particularly in the flood time, it was shows negative. So let me come to the following slides. What are the recent beacon these? And this H. This is a chlorophyll. This is chlorophyll concentration during the period. So chlorophyll not that much concentration the bloom dynamics and wind stress skull. So negative wherever the bloom catching. So that where we have to see negative values of the wind stress skull. So these parameters how influenced in this dynamics. So these are things. So positive wind stress lead to upwelling period. So where the wind pushes surface water, allowing nutrient-rich water comes from the beneath to surface. This nutrient enrichment promote the growth of phytoplanktons and source for the jellyfish. And this positive influence ocean current aiding to the transport of both jellyfish and their prey. This can lead to the aggregation of jellyfish in specific areas contributing to the formation of blooms. At the same time, negative wind stress associated. So here we can see the negative wind stress. This negative wind stress is associated with the condition that typically suppress upwelling. So this time naturally reduced nutrient supply. So lead to decrease the nutrient availability and may impact the productivity of the marine ecosystem in this region. And northward movement of wind may influence surface current, transporting jellyfish and the prey to the specific region. This transport along the positive wind stress induced upwelling can lead to aggregation of jellyfish contributing to the bloom formations. Upwelling associated with the negative sea level anomaly. So I already told that negative sea level anomaly and favorable wind condition so lead to upward movement of the nutrient-rich water from deep water to surface. The decreasing trend of salinity combined with other favorable environmental conditions may contribute to the proliferation of jellyfish by creating suitable conditions for the growth and reproduction. The jellyfish blooms are observed during a period of negative wind stress curl. It suggests a unique environment condition that favor further proliferation. And this is the temperature and salinity and density longitudinal plot of vertical variation. And these two for the non-catching time. A part of other time is completely catching during the time of jellyfish catching. So it was an upwelling signal. Thus, the thermocline layer it was shows towards the uplift of the directions in coastal areas. So this shows to the upwelling signal in that particular time. When the time of we can catching more. So that time it was an upwelling signal in 2018. So in this signal, so it was the same signal shows in that way, but here we can get more jellyfish catching due to the downwelling time. So the signal shows all the things. And here in salinity, the same, here the low salinity were not mixing, that much mixing. So here we can able to see the stratification, some more mixing zone in that particular catching areas. And other areas, it was less mixed depth area. Water was not that much mixed, so mixing was mixed very less. The same situation we can seen in the happen in 2019 also. So that is the time during more pronounced jellyfish catching. And this whether due to the factor upwelling or reverse discharge, it can influence the distribution of abundance jellyfish. Some species are more tolerant in varying salinities, while others are more sensitive, sir. So in particularly in Cochin Coast is located in Cochin backwater, so it was more influenced from the river discharges, sir. And this time negative Ekman pumping can contribute to water column stratification. So that we can see in this figure in the stratification levels. And where surface water becomes less mixed with the deeper waters. This stratification may influence the vertical movement of jellyfish, allow them to stay within a specific depth ranges that are conducive to their feeding and reproductive behaviors. And as we know, the Ekman pumping, what is that? Vertical movement of water caused wind-induced Ekman transport, which is net movement of surface water towards the 90-degree direction, right angle to the wind directions. Offshore transport. This wind caused surface water to move away from the coast, creating a horizontal transport known as Ekman transport. This transport lead to the deficit of water near the coast, contributing low level of sea level. And upwelling dynamics. As the surface water moves offshore, nutrient-rich water comes below to replace in the surface. This process enhances vertical mixing and nutrient supply in the upper layer, benefiting marine ecosystems. And offshore movement of water results in a temporary decrease in sea level near the coast. This negative sea level anomaly reflects the physical displacement of water away from the shoreline during upwelling time. So during the time of upwelling, it was suppressed upwelling. So our parameters positive Ekman pumping tend to suppress upwelling, and also negative wind stress associated with the condition that typically suppressed confirm that upwelling. Leading to reduced nutrient availability and in surface water. This can lead to decrease in nutrient availability near the surface and may impact the productivity of marine ecosystem in this region. And this is this plot shows represent the surface current, and red color shows the northward movement, and green and other blue color shows in southward movement of the surface current. So upwelling is associated with offshore surface current. Wind that drive upwelling causes surface water moves away from the coast, leading to upward movement of colder and into its deep layer. As a result, there is a typically offshore transport of the surface water. So during upwelling, offshore transport of water can create temporary decrease in sea level near the coast, resulting negative sea level anomaly. So by the time only we can get in southwest summer monsoon, particularly jellyfish intensity is jellyfish bloom, but intensity is very less. But rest of the northeast monsoon during downwelling, intensity is more in the bloom period. So while upwelling is generally associated with the negative sea level anomaly due to offshore surface currents. And come to the summary of findings. What in a positive Ekman pumping occurs when the wind blows same directions as the movement of surface water. As we know, then a 90-degree angle of the wind directions. So the positive Ekman pumping while the wind is blowing southerly directions. This means that the wind is causing surface water to move from north to south. The resulting vertical movement water is upward. This upward movement can contribute to lift nutrient-rich water, which is associated with the process such as upwelling. But this has enhanced nutrients. But negative wind stress is associated with the condition that normally suppress upwelling, leading to reduced nutrient availability in surface water. This can this can affect the productivity of marine ecosystem. At the same time, in northeast monsoon, negative Ekman pumping is northerly wind, which means move surface water from south to north directions. So it is negative Ekman pumping is accompanied with the positive sea level anomaly. It indicates the combination of factors causing a temporary sea level rise near the coast. A positive level anomaly can result in the accumulation of water due to factors such as convergence of surface current. This condition is associated with the suppression of upwelling, resulting low nutrient level. This also affects the productivity of marine ecosystem in this region. So both that phenomena, upwelling and downwelling, seen in the nutrient level deficit the nutrient level. So when the time of nutrient deficit, the jellyfish can come to the surface water. So let me compare to that southeast monsoon, the nutrient deficit is low because of suppressor of upwelling. By the time jellyfish bloom happened, but intensity is low. But at the same time, intensity is more in northeast monsoon, the completely nutrient deficit time. So it can come to the when the time of means we can able to see that period. Nutrient deficit time now. So by the time only the bloom has happened by our thank you.